Hi, welcome to 6.5 Notes. We're going to be talking about the properties of logarithms. So let b, m, and n be positive real numbers where b is not equal to 1. And you can look back at previous lessons if you want to refresh yourself on why we want that to be the case. The product property, we're talking about when we see that something is multiplied, we know we can expand it by adding, or if something is added, we know we can condense it using multiplication. So that just says log base b of m times n is the same thing as log base b of m plus log base b of n. And with the quotient property, if we see something is divided like that, we can expand it by writing it as a subtraction problem, or if we see the subtraction, we could condense it as writing it as division. So log base b of m divided by n is the same thing as log base b of m minus log base b of n. And the power property tells us that when we have that exponent up here, that can be dropped out front, and so log base b of m to the n power could also be written as n times log base b of m. So we see here that kind of multiply and add go together, and we can see here that divide and subtract. Those are those things that we're going to remember when we try to either condense or expand those expressions. Now the change of base formula, again, a, b, and c are positive real numbers. We don't want b to be 1, and we also don't want c to be 1. Then the log base c of a is equal to the log base b of a divided by the log base b of c. So in particular, we're going to look at this where it's the log base c of a equals the log of a divided by the log of c, and the log base c of a can also be written as the natural log of a divided by the natural log of c. So that kind of gets rid of that base number and puts it in the common log. We're going to take this one and we'll divide it by this one. Okay? So we'll see an example of that here in just a minute. For some worked examples to help us see these in action. Okay, so let's start. We're going to condense this logarithmic expression. So remember, condensing, we've got log base 2 written 2 times, and we want to condense it down to where it's only stated once. So the first thing that I notice is that there's a plus. So I know that means that I can multiply. And what I will end up with is I'm going to write log base 2 one time, and then I'm going to take the 3 and the 8, and those can be multiplied together. So if I simplify that a little bit, log base 2 of 24 is the same thing. I've condensed these to get that. So it's the same thing as that. And let's see, for this one, I notice that I have a subtraction. Well, I know that if I have subtraction, I can condense that using division. So I'm going to write my log base 5 one time, and then I'm going to, before we do that, let's take a look. Something almost slipped by me here. I see this 2 out front, and I know that I can move the 2, so let's move that. Almost made it past us. We're going to move that 2, so what we have is actually 5 squared. And what is 5 squared? Well, that's 25. So I've got my log base 5 written once. Let's pick that back up where we had. And I've got my subtraction, so I know I'm going to take this top number and I'm going to divide it by this number, which is what that is right there. So I'll have my 4 divided by 25, and that is the same thing. It is just a condensed version. Okay, and let's not let it slip past us this time. Let's look. I've got that 3. Well, that's going to become my exponent. So what I'm really looking at is the natural log of 6x to the 3rd power plus the natural log of 4y. Well, I see that there is a plus. So I know that I'm going to write this with multiplication. Okay. So I'm going to write my ln just one time because I'm condensing it. And then I'm going to take my first term, that's 6x to the third, and I'm going to multiply it times my second term, which is that 4y. And there you go. You have it. That is the same. This one is much the same, but it looks more complicated just because there's 3 terms there. So I'm going to break this up. I'm just going to look at this part, and then I'll deal with the other one. So first, let's look at it all. This is the only one that's got that can become an exponent. So let's see, if I'm going to move that 1/3, that becomes 27 to the 1/3 power, which we know is the same thing as the third root of 27. Again, that can be simplified. So this whole term here becomes log base 2 of 3. So I'm just going to kind of rewrite this really quickly so that we can look at what we're doing. We've got log base 2 of 625 minus log base 2 of 125 plus log base 2 of 3. So this is kind of what I've simplified and moved things around. Now I can work with this. And this is where I'm going to condense it. So let's first look at that beginning part that I underlined in the beginning. So I see a subtraction, so I know I can write this using division. So I'm going to write my log base 2 just one time. And I'm going to write that first number divided by that second number. Okay. And now what I see next is that over here I've got a plus, so I know I can write that using multiplication. So what I'm going to do is I'm going to multiply my 3 to that. So I have the log base 2 of 625 divided by 125 times 3. So let's simplify a little bit. 625 divided by 125 is 5. So if I look at that, 5 times 3 is 15. So this is the same thing as this, just written in a condensed form. So let's turn the page. And for this, I want to remind you of, again, that change of base formula. So basically, we know that if we've got a log of something, a log base something here, we can take the log of the A and divide it by the log of the C, or the natural log of the A divided by the natural log of the C. This is helpful sometimes in calculators. You can't put that some calculators you can't put that subscript number in, and this is an easy way to get it all log base 10. Use the common log and get an actual answer for it. So here it says to just evaluate the logarithm using the change of base formula. So it's very specific. So I'm going to just start by writing the first one is log base. Well, my big number is 17. So it's actually log of 17. It's now got that common log, 10 log of 3. And then I can put that in my calculator. When I put that in my calculator and I round it, it'd be 2.579. And it's just as simple as that. I'm going to take the big number divided by the little number. So log of 294 divided by log of 9. And here the fraction doesn't matter, so it's log of 4 over 9, and you'll divide that by the log of 7. Negatives are okay, don't be afraid. And again, we're just going to treat that fraction like any other number. Put it in your calculator. Feel free, because I know I'm moving kind of quickly on this, but that's just because you can pause when you need to pause and let everyone work at their own pace. Okay, finally, let's do an application problem. So Hicks' law states that a given n equally probable choices, such as looking at a menu, choices on a menu, an average human's reaction time is t in seconds required to choose from the choices is approximately t equals a plus b times log base 2 of n plus 1, where a and b are both constants. In this situation, if a is 4 and b is 1, how much longer would it take the customer to choose what to eat from a menu of 40 items than it would from a menu of 10 items? So I'm going to start by just writing that t equals a plus b times log base 2 of n plus 1. And it tells me that a is equal to 4 and b is equal to 1. And it wants to know how long, so I'm going to be solving for that t. But there's two different situations. The first situation is when I have 40 items to choose from. So let's just go ahead and substitute in what we know. Well, t equals, what's my a? 4 plus, and then I've got 1 times log of 2, and then my number of items on there is 40. So let's simplify this a little bit. 4, and then 1 times anything is just that anything. So I'll say 4 plus log of 2. 40 plus 1 is 41. Now, in my calculator, I would want to make that a change of base, just to enter that in my calculator. And I would make sure that all my parentheses close this off. I added 4 to it, and it would give me 9 minutes, 9.358 seconds, actually, I believe. And let's see how much longer that is than if I had 10 items to search from. So here I'd have t equals 4 plus 1 times log base 2 of 10 plus 1. Okay. Well, I've still got my t equals 4. 1 times all that stuff is just going to be all that stuff. 10 plus 1 is 11. Using that change of base formula, I would find out that it should take me about 7.459 seconds. Okay, so I've got two different outputs there, but what I want to know is how much longer. So that means I have to compare them. I'm going to subtract my 9.358. From that, I'm going to take 7.459. And it says, so basically I know it's going to take about 1.899 seconds longer to look at that menu if I've got 40 things to choose from instead of 10 things to choose from. And that is it for the notes for 6.5.